Okay. So we managed to overcome this other challenge and make sure that the copy constructor works well. So let's turn the page and say, well, look at this. Is there a better way for me to organize my lists? If I'd like to have a list, could instead of managing individual nodes, could I instead have a big object just like this, which will provide a simple interface to insert and remove the data. But internally, it will organize its own nodes and it will maintain all the links for me. Standard library list is such object. So perhaps what we could do with this example is that we can close the solution and quickly create a brand new one, new project, and name it new project, another console application, and we'll name it STD list demo, something like that. All right, so it'll create this project folder, and hopefully we can use this example. All right, so okay, so we have this empty project. Add main. Make sure you're pointing to the right file type. Add that. All right. So int main as always, right? So just a very simple approach to this. And this is the second demonstration for what else you can do, is to say include standard header list. And this gives us access to the standard library implementation of list, which does this. Gives you an interface to manage the data inside the list, but you don't get access to individual nodes. You sacrifice the node for the convenience of using a different interface. So let's take a look. So we can basically take this out and try this in our main function. So we can quickly examine this, apparently using to satisfy this, and also I need to include IO stream because it's using console output. By the way, this is not the only way to to avoid using STD. Namespace name in front of list or in front of cout. Another alternative to this would be to explicitly go and inside here say using std list. Okay, and well, perhaps I need to specify the type qualifier as well here. No, I need to check on the syntax. Of course I can do this. Oh, not namespace, just using. And probably I don't need this. Right. So problem solved. So if you just don't want to infuse the entire standard namespace, you can be using those using directives. So just an alternative to this using namespace at the top, you can go at the level of individual function and start saying what you want to use. All right, so here's an example. Apparently, the list comes from the library header as the template which is based on other types. So the library is designed in such way that it says list will be the same for integers and doubles and other objects, and what you need to specify when you create a list, you need to use those angle brackets. This is not less than or greater than. These are technically called angle brackets, and we say this is a list of integers. Okay, and if I had something like this, class foo, whatever, right? And it contained some data here. Let's use struct. We never use struct. We could say int ABC double def, and maybe a boolean I don't know, XYZ, something like that. So then I could also have a list of these structures by saying list of foo. That's how convenient and powerful this is. Now the arguments, so this is an example. So let's go back to the integer example first. So I can have a list of structure like this, or I can have a list of integers, or you can create list of anything you want. So this particular constructor, basically what it does, it says that I want to construct. Let's actually check what it says here. Function for insertion to ins. This type of constructor will create a list with 2 nodes to begin with. This type of construction of list will create an empty list. And the one that we use here is say we want 2 elements, and we also want to store values 100 in each one of them. And I'm not sure what this will do with the struct. I don't want to go into this right now. Let's just go through the example. So initially this list will contain basically 2 nodes which contain 100 pointing to another 100, and then finally pointing to a null, right? Then we say push in front of the list 200. So I'm expecting this to become 200 pointing to whatever this was, right? So we inserted 200 in front. Then we say push front 300, so the list becomes then becomes something like this. So arguably, for cases like with structures or integers, if you want to maintain a list of those nodes, arguably this is an easier way to maintain the list. Create this mothership object, my list, right, of a list of integers, and then use my list to do everything with the list. Push front, push back. Now here's an example of pushback. So in case of a pushback, what's going to happen is that we will insert 555 at the end of the list. Something like that will happen, right? So this is how you can manipulate the list using the list object of the standard library. And say my list contains, so now we want to show the content. And here is an iterator, let me demonstrate what iterator is. So if I manage to construct this kind of list, let me just clean this up a little bit. So the list here also provides a helper object named iterator. Today we're sort of covering this informally just to get a taste of it, but there will be a time when we cover it more formally when we talk about the standard library. Let me